Hello, it's me Kuber Loha, and in this video we will discuss the diode characteristic and how we rectify. So basically, the diodes play crucial role in signal processing and power conversion application. Okay, and the behavior of diode is particularly in their current voltage characteristic. So these are the components required for this experiment. That is one diode and one kilo ohm resistor and 10 kilo ohm resistor. Okay, and one capacitor which is suitable for filtering and ADLM kit and multimeter. Okay, so you can see this is the circuit of this diagram of part 1. Okay, and let's make it in practically. I have set all this component as per this diagram, and this one is diode and this one is 1 kilo ohm of resistor. Okay, now I'm just going to connect channel A at this point, and this green color wire connect in ground at this point. Okay, now I have to measure current at this point. Initially this voltage is 0 volt. Now increase this one 0.1 voltage. Okay, 0.11 voltage, and still current is 0. Let's do in a bigger number, which is 0.22. Still current is 0, and let's do in 0.39. Still current is 0. We have to now increase current voltage 4.9. Let's do this one, and now you can see it is 1 basically, but something is wrong in this thing, so that's why it is 0 and 1, 0 and 1, like that. Okay, so this voltage is known as breakdown voltage. That's why at this voltage, from this voltage, current will start increases. Okay, now increase the voltage from this point. Let's do 5, and you can see this is 0.3 or 0.2, like that. Okay, you can see this is the graph of IV characteristic of diode, and initially we took 0 voltage and we got 0 ampere current, obviously, and from 0 to from 0 to 0.49 we got 0 ampere current, and after that 0.49 volt is, that is breakdown voltage, and after that we called some value of current, and that is I mean, after that when we increase the value of voltages, it is current also increases. Okay, so this one is part 2, and I have set all this component as per this diagram. I replace this 1 kilo ohm resistor with 10 kilo ohm resistor, and I use one resistor for this. Instead of this resistor, I can directly connect with this gate and take 2.5 volt of DC, but we have to take 50 hertz of frequency also. That's why I connect this resistor. Now whenever I rotate this resistor, I can change amplitude. Okay, so you can see when it is increasing, this is increasing. uh, okay, so this is the waveform of this, but this is not pure DC voltage. So for making DC voltage, we need to connect one large amount of capacitor in parallel. Okay, so I have this capacitor which is 100 microfarad. So let's connect this one in parallel, and you can see that it's slightly becoming straight, and basically it is slightly becoming DC voltage. But whenever I use more than this 100 microfarad, it will become a straight line, and that is known as pure DC form. Okay, so now, but unfortunately I don't have a large amount of capacitor after that. So now I'm just going to calculate the rectification of that. Now you can see rectification efficiency, which is 40.6, and ripple factor is 1.2. So for 0.5, I replace this diode into LED, and I have to give 1 hertz of frequency, and I give 2.5 volt. You can see, and it is blinking, but very slowly. Whenever I increase the value of, whenever I increase this voltages, now it is slightly increases. Okay, you cannot see, but it is increases. But when I increase the voltage, let's increase the frequency of this one. If I increase, this is 100, then you can see it is still blinking, but it is very low. When I increase this from 1000 frequency and 5 volt, you can see this is start blinking at a very high power. Okay, but this is not pure DC voltage. If I connect this capacitor in parallel, now you can see it is properly dimmed, this light. Okay, so still it is not properly purely DC voltage, because my capacitor is not very big value. It is just 100 microfarad, so that's why. Okay, so this is the last part of this experiment, and I have to replace diode in generator and 1 kilo ohm resistor to 200 ohm resistor, but I don't have 200 ohm resistor. That's why I use this 330 ohm of resistor. Okay, now let's increase the voltages, and you can see whenever I increase the value of this one, whenever I increase the value of this one from 0.11, it's nothing change. And 0.012, 012, let's try this one, 012, and it showing nothing. Let's try in a bigger number, 0.66, and I think you cannot see, wait, it is showing 1. Okay, so in 0.66 volt it's showing 1. Let's increase this value, and this is the breakdown voltage of this general diode, and I have to use a bigger number, let's 77, and its value increase, you can see its value is from 0.5. And one more point, what if I change its reverse, in its set in reverse bias, then you can see currents cannot flow. And the final one is that this is the IV characteristic of general diode, you can see. So this was our experiment 4.